Now we're going to follow up and continue our discussion about graphing. So, as we always do, we'll go backwards before we go forward just to quickly review what we've said already as we move ahead. So we know we have these two axes, y and x. We have the origin. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We know that to plot a point anywhere on the coordinate plane, we need two values, an ordered pair, where x is first, then y. X is first, then y. X is first, then y. These are ordered pair configuration. X is first, then y. Once we have that, or once we've talked about that, we kind of know where points are even before we plot them, because everything in quadrant 1 is plus, plus. Everything in quadrant 2 is minus, plus. Everything in quadrant 3 is minus, minus. And everything in quadrant 4 is plus, minus. Now, here's the step forward that we're making right now. We've talked about all the points that are in quadrant 1, in quadrant 2, in quadrant 3, or in quadrant 4. Now it's possible, because we have these numbers. I won't put the numbers, but I'll just put the marks. You know that you would just be counting. -1, -2, -3, -4, -5, -6. Positive 1, 2, 3, 4, 5, 6. -1, 2, 3, 4, 5, 6. So I'm just going to put -6 here. Positive 1, 2, 3, 4, 5, 6 here. 1, 2, 3, 4, 5, 6, and -6. So you know that this is negative, that's positive. And positive 6 here. So I have -6, -5, -4, -3, -2, -1, 0. That's the origin, 0. So the coordinate at 0 is 0 for x and 0 for y. It didn't go up and didn't go down. It didn't go left and it didn't go right. So it's at 0, 0. So the origin, the coordinate for the origin is 0, 0. It's 0 for x and 0 for y. Now you notice that the origin is not in quadrant 1, it's not in quadrant 2, it's not in quadrant 3, and it's not in quadrant 4. It's at the intersection of the two axes. So it's not inside any quadrant because it's on the axis. So this is what we want to talk about right now, just so you see the clarification. The only points we haven't talked about are points that are on the axis, which means they're not in any quadrant. They're on the axis. So for example, the coordinate for this point is 0 for x and 2 for y. It's on the axis, so it's not in any quadrant. This point, for example, the coordinate for this point is -6 for x and 0 for y. It's 6 units to the left of the axis, but it didn't go up and it didn't go down. So the y value is 0. It's on the line. So we'll do one more. Well, we can do more than one more. So let's say we do this point. If you follow what I'm saying, you know the coordinate for that point is 5 for x, and 0 for y, because it didn't go above the line and it didn't go below the line, or didn't go above the x-axis. It didn't go below the x-axis because it was on the x-axis. So let's take another. What is the coordinate right here? It's 0 for x, because it's not left. It's not left and it's not right. It's on the y-axis, so it comes down 1, 2, 3, 4. So it's 0 for x and -4 for y. So now we've clarified anywhere a point could be on the coordinate plane. It's either in one of the quadrants or it's on the axis. Either it's on y-axis or on x-axis. If it's not on the axis, it has to be inside one of the quadrants. So now we've covered all the points, and this is what I'd like to show you right now. If I had a ruler, that will make this really straight. So let's imagine we had a line that was a straight line and it went through those 2 points. And it kept going because we know the lines keep going, so I'll put the arrows here. So that's one line right there. So say we have the other line was right here. It's not coming out too dark. So this is my other line. So now I'll keep going because I know my line keeps going indefinitely, infinity. So now I have two lines. One is green and one is pink or reddish. So you can see the 2 points that we put down where the line crosses. So this is the key reason that we're talking about this right now. You see this point right here. We call that the x-intercept. I-N-T-E-R-C-E-P-T. Because that's the point at which the line crosses the x-axis. So that's the x-intercept. This is called the y-intercept. T-E-R-C-E-P-T. That's the point at which the line crosses the y-axis. Now, you can see now, you will call this point will be the the y-intercept, because the pinkish line crosses the y-axis at that point. That will be the y-intercept. Intercept means crossing. And this would be the x-intercept. So I'm going to put this out here and say x-intercept. So now we have two lines. They cross the x-axis and the y-axis. So we have the point at which they cross the axis is our intercepts. So when the line crosses the y-axis, the x value is going to be 0 because it's not right and it's not left. When the line crosses the x-axis, the y value will be 0 because it's not up and it's not down. So these are helpful tools for us when we start to work with linear equations in a fairly short period of time. So you'll see how useful the intercepts are. So now let's talk about what is the meaning of this word linear. This word linear means a straight line. So linear, straight line. Like here's a line, but it's not linear. The blue line is not linear. It's a wavy line. It's not separated, it's continuous, but it's not straight. So it's not a linear description of this pattern that I've put here. It's a line, but it's not a straight line. For example, this is a line, but it's not a straight line. So linear means straight line. Now, an equation, which you've seen before, so we're just going to remind ourselves, an equation, I'm going to write it right here so you can write it down for yourself later. Equation. An equation is an expression, it's a mathematical expression that two things are equal. I'm going to write that right here. I'll say math instead of mathematical. A math expression, expression, that two things, we'll use things for right now, but even though they're things are equal. So the word things will change later to a more sophisticated terminology so that people will know that we're strong math students because we understand the proper vocabulary. A math expression that two things are equal.
A long, long time ago, before time began, nature was still creating all the animals of the world, trying to give each animal something special. And nature had given Anansi the spider the ability to spin webs to catch all the bugs. Well, some of the bugs. Anansi walked past all the animals in the jungle. They were proud of what nature gave them. Anansi respected them all, which was fine, except for one thing. None of the animals respected Anansi. Well, at least that's what Anansi felt. But then he had an idea. He would find the most respected animal of the world and get his respect. Then all the animals would respect Anansi. And that was Mr. Tiger. Everybody respected Mr. Tiger. Anansi went over to Mr. Tiger's house and waited for him to come out. But when Mr. Tiger finally came out, he didn't even notice little Anansi waiting. Wait now! Yes? Mr. Tiger, how can I get your respect? Get my respect? Well, Mr. Tiger nearly laughed his tail off at such a request. But Anansi didn't care. Anansi was determined to get Mr. Tiger's respect. Well, okay. If you bring me Mr. Snake, the grumpiest creature in the entire world, Only then could I respect little you. Bring Mr. Snake? How was Anansi gonna do this? Well, every day Anansi carefully studied Mr. Snake. What he ate, what he drank, and when he would rest. So now that Anansi knew Mr. Snake's routine, Anansi decided it was time to lay a trap. Oh, the poor thing. Well, Anansi realized strength was not the way to catch Mr. Snake. He would have to try something else. Then Anansi found the answer he was looking for. The next day, Anansi poured grease along the inside of the pit, hoping the snake would slip and fall in while trying to eat a whole hand of bananas. This was not the case. Did you actually think you could catch me? No, Mr. Snake. I was curious to see if it was true. Curious of what? Anansi? That I like eating spiders? No, not that. I was just curious to see if you were the longest creature in the jungle. Longest creature in the jungle? What? Man, I am the longest creature in the whole world. Bring me anything, and I will prove that I am longer. Anything? Even longer than a bamboo pole? No one's longer than that. Bring it so, and I will prove to you I am. Well, you better stretch out your belly so, because this pole is mighty long. Don't you worry about that. You just keep measuring so. And Anansi did, spinning his web tight to tie Mr. Snake to the pole. Well, Anansi, I am so impressed at what you've done. I will now grant you some respect. Thank you, Mr. Tiger, but I don't want your respect anymore. Well, not if it comes at the expense of someone else's feelings. Sorry. And nature was proud of Anansi. So proud that nature gave him a magical gift. The gift to make intricate webs that were incredibly sticky. So now he could catch all the bugs.
So let me give an example of one. So we'll say example number 1. You've seen an equation because an equation is separated by a sign. Let's say I say 2x equals 10. That's an equation. It's an expression that two things are equal. And the equal sign tells me that it is an equation because the equal sign is the expression that notifies us that two things are equal. So here we have an equation, and if I said to you, well, what is the value of x if 2 times x equals 10? And your mind would tell you pretty quickly that 2 times 5 equals 10. So x would have to be equal to 5. Your mind would tell you that because you can see that 2 times some unknown number that equals 10 would have to be 5. So what if we had example 2, EX number 2? What if I said 3 times x equals 27? If you know your multiplication tables, you can see that immediately, and you would know that 3 times some invisible number that equals 27 has to be 9. 3 times 9 equals 27. So you would say x has to be equal to 9. So that's the basic, simple solution to an equation. So when we get to, I'll give you a repeat of how we deal with equations generally, but before we come to that, we'll just do some plotting first, because we don't have to solve equations actually to do a lot of our plotting, at least initially. So I'm going to erase some of this to give us a little more space to work on. And then we will continue with what we're doing. So I'm going to take this out. You can go back to it, of course, on the tape. That's no problem. Now, right now I'm going to do two things at the same time because I feel like you can do it, and students have always done it, so that came before you, so there's no reason for me to assume that you won't be able to do the same thing. Now, many of you have nicknames. So, and everybody knows that the nickname describes you, even if they don't know what your real name is. So, we have a nickname for linear equations too. Linear equations look like this. When we see it, y equals mx plus b. That's a nickname for a linear equation. It's just written like that. So I'm going to leave this for right now. We don't need it right now. But here's an example of what it would look like if we didn't have all the letters. Let's say it would say y equals 2x plus 6. Now there's an equation of a line. So the question that we have first is, how do we figure out what are some of the points on this line? Now we know that in order to have a line, we have to have ordered pairs. So let's say we're going to have ordered pairs, so we make ourselves a little chart. We make ourselves a little chart. X and Y. Those are going to be coordinates that tell us what the line looks like. So now, how do we work with this? We know we have to have ordered pairs to make a line. Now we can see right here that it only takes, and this is important, it only takes 2 points to make a line. Because if I have any 2 points, I can connect them with a line and I have the line. So I don't need hundreds of points. Even though I know there's an infinite number of points on this line, I only need any 2 of them to draw the line. So here's how we work it. This gives you a chance to be the one that decides things. So here's our line, and we need at least 2 coordinate points to figure out where the line is. So you say to yourself, what if you pretend, you say, if x equals 0, if the x was 0, 2 times 0 would be 0, and then y would have to be 6. If x is 0, y equals 6. So you just put 0 in place of x, and you see 2 times 0 is 0. So the only thing left is y equals 6. So one point you say is 0, 6. That's also, if you follow what we said, that's the y-intercept, because 0, 6 is this point right here. I hope you're following this okay. That will be 0 for x and 6 for y. That's one point that'll fit this equation. When I say fit, I mean it makes it a true statement. So if y is 6 and x is 0, 6 equals 6. So that's a true statement. Then I would go back and say, what if x was 1? If x equals 1, then 2 times 1 is 2, plus 6 is 8. If x is 1, y would have to be 8. So I would put 1 and 8. Now I wouldn't have to use these numbers because there's an infinite number of values that will make this equation work. What if we went one more and said, if x equals 2, then you say y would be what? My markers are getting a little bit dry too. If x was 2, then I put 2 in place of this x, which would be 2 times 2 is 4, plus 6 is 10. So y would have to be 10. So if x is 2, y would be 10. I'm going to make these a little darker so you can see it clearly. So now I have 3 points on this line. So where are these points? See, if this is 0, 6, I have 1, 8, 1, then I have to go up to 8. So see, I need to erase this so our line can be plotted. So I'll take that out so that there will be no interference with our plotting. Because we don't want our line to be crowded with those words. Then you won't be able to see it clearly. So the next point we have is 1, 8. I have to find a marker that is really good for you because I want you to be able to see very clearly what we're writing. So the second point is 1, 8. So I go over 1 and up 6, 7, 8. So there's 1, 8 for my second point. So I could stop right here because I can see with just 2 points I can draw this line. But let's go one more point. 2, 10. 1, 2, and go up to 8, 9, 10. So 2, 10. So now I could say, here's my line coming just like this. I'm making it a little crooked though, but and if it keeps down, I can see that it's going to cross this line if I extend it. It's already crossed that line. And you can see if this keeps going and that keeps going, somewhere they're going to cross out here. So I'll put a little arrow here because this line has a lot more points on it. Now we will say, I'll check one other thing with you just to see if it makes sense to you. So in order to do that, I need a little more room. So you'll have this already. So if I said to you, if I asked you, how many points, possible points, are on this line that we're making, you would say, Dr. Whitaker, it's an infinite number of points. So I would then say, okay, that's very good, because you know that a line goes on to infinity in both directions. And we have 3 points on this line. What if I ask you, is this point on the line, 3, 11, is that a point on this line? You might say, you don't know. Then if you said that, I would say, well, how would you find out? And you might say, we don't know. So I'm going to show you, and then the next time you will know. So I'm going to make this a little darker. Y, this is our equation. Y equals, this is our linear equation. We know this will make a line because we've already made a line. And our question now is this point, which is identified by the coordinate 311, is this point 311, is it on our line? That's what we want to know. Now, how can we find that out? Well, it's fairly easy. If x is 3, I would put 3 in place of the x, plus 6. So this is called substitution, and that's a word that we will need when we go forward down the road. So I would substitute the 3 for the x, which means put the 3 in place of the x. So this is substitution, S-U-B-S-T-I-T-U-T-I-O-N. Any two things that are equal could be substituted for each other. Most of you have an idea of substitution. If you go to a restaurant and you order something from the menu, but you don't want everything that comes with that meal. So you frequently ask the waitress, for example, if it has mashed potatoes and you want French fries, you ask, can I substitute French fries for the mashed potatoes? They're both potatoes, and if it doesn't change the cost of the meal, you would very much like to have the French fries instead of the mashed potatoes. So you ask if you could substitute the mashed potatoes for. Or it's like in a sporting event. A basketball game has 5 players on the floor. And when the coach decides that one player is tired, the coach substitutes another player for that player, so that you still have 5 players, but one is a substitute for the other one. So that's the idea. For teachers absent, that's why you call the person that comes just for that day a substitute teacher. They're taking the place of the teacher that's normally there. So here's our equation. It says x is 3 and y is 11. So I have y will be 11. And the question is, does 11 equal 2 times 3 plus 6. So let's see. 11 equals 2 times 3 is 6 plus 6. So 11 equals 12. And you say, no, 11 does not equal 12. So that tells me that this coordinate, 311, is not on this line. I mean, the line we're talking about. 311 is not on it. 311 is someplace else. So that's how we would check to see if a point is on a particular line. We simply substitute the x value for the letter x, and we substitute the y value for the letter y and see what happens. Is it equal? In the example we use, we substituted the 3 for the x, the 11 for the y, because those were the coordinate. That was the coordinate, 3, 11, which was in quadrant 1 because they were both positive, but it didn't work. So we know this particular point, 3, 11, is not on the line with those other 3 points. So if you can follow that, it really gives us a big, big head start on what we're talking about and what we're going to be talking about. So, it's been 29 minutes that we did that. So I'm going to stop here, and then we'll come back and continue. Now, you don't have to understand all of this perfectly right now, but you'll have it there. So we're going to stop. I'll clean the board, and we'll come back.